All right, we are going to be looking at real numbers, the real number system. So this chart right here is going to be really helpful for you. We're looking at the different types of numbers that fall within the real number system. So first off, what are real numbers? So real numbers are all numbers that can be represented on a number line. So they can be classified according to their characteristics. They are made up of rational and irrational numbers. So basically, every number that is real. You might be like, well, isn't that every number? In the future, you're going to get into some math courses that talk about imaginary numbers. That's why we kind of define them, real numbers versus imaginary, but we will only be working with real numbers. So we have irrational numbers, which is a number that cannot be expressed as a fraction. So it is non-terminating decimal. So for example, 5.4371 going on forever, that doesn't repeat and doesn't end. They are irrational. Then you have rational numbers. So that's the opposite. They are numbers that can be expressed as a fraction. It includes positive and negative numbers, whole numbers, fractions, terminating and repeating decimals. So almost everything is a rational number. Anything that's not is irrational. Integers are your positive and negative counting numbers. So when I say that, I mean, if I asked you to count to 10, you're not going to say 0.5, 0.75, 1, 1.2, 1.8, 2, and so on. You're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's those positive values and those negative values. Whole numbers are all positive counting numbers and specifically including 0. So no fractions, no decimals, no negatives. Natural numbers are almost identical to whole numbers except that it does not include 0. The reason how I remember that is 0 is kind of not natural. It has special case scenarios when you're multiplying, when you're dividing, and so on, that it's kind of not natural. So you can kind of look at these charts, and it's like when you think of rectangles or squares or parallelograms. Every square is a rectangle, but not every rectangle is a square. Or every square is a parallelogram, but not every parallelogram is a square. So it's kind of categorized that same way. So in this chart here, you've got they're either irrational or rational. A lot of times our square roots are irrational, and pi is also irrational because it goes on and on forever without repeating. And then you've got things. So the whole number 0, since it's in this category, it's also an integer. It's also a rational number. -3 is also a rational number. But this rational number that's a fraction is not an integer. So they can go out this way, but not back in. So let's look at what this means. We're going to be looking at these numbers and categorizing them, putting a check next to which ones they apply to. So as soon as I see a negative, I know it's not natural, I know it's not whole. Since there's no decimals or fractions, it is an integer, and automatically, if it's an integer, it's also a rational number, and it's also a real number. The number 0, remember 0 is not natural, but it is a whole number. Once it is a whole number, it is also an integer, it is also a rational number, it is also a real number. Number 4, that is a natural number. So remember, every positive counting number is a natural number. So if it is natural, it is also whole, it is also an integer, it is also rational, it is also real. 14/5. So right away I see that it's a fraction, but you should always double check. What does 14/5 give you? It gives you 2.8. So it does give us a decimal. As soon as it's a decimal, it's not natural or whole. It's also not an integer once it has a decimal. So we know it's a rational number because it's a decimal that ends, which means it's also a real number. 24.66, since it's a decimal, it's not natural, it's not whole, it's not an integer. Since the decimal ends, it is rational, not irrational. If it's rational, it's also real. All right, the square root of 7. I'm going to double check on my calculator. Square root of 7 gives me a decimal that does not repeat and keeps going on forever. Those are irrational. Remember that we said a lot of times the square roots are irrational. Every single number that we are working with is within the real number system. So if it's irrational, it's also a real number. All right, 1.3, as soon as it's a decimal, it's not natural, it's not whole, it's not an integer. The bar over the 3 says the 3 is repeating. Repeating decimals are rational. If it's rational, it's also real. -2/5. So that fraction's a little bit easier to see, but if you calculate it out, it still is a decimal. As soon as it's a decimal, it's not natural, it's not whole, it's not an integer. Since it can be put as a fraction, since it's a decimal that ends, it is rational. If it's rational, it's also real. All right, -0.4 repeating. As soon as we have a decimal, not natural, not whole, not an integer. Since it's repeating, repeating decimals are rational, which means it's also real. All right, 2 square root 5. If I plug that into my calculator, 2 times the square root of 5, I get a decimal that goes on and on forever without repeating. That is irrational. And again, everything is real. Here I see the square root of 625. Now be careful looking at that, because when you plug that in, we actually get a whole number of 25. Any positive counting number is natural, which means all of these other apply. It's a whole number, it's an integer, it's rational, and it's real. The only thing it isn't is irrational, because it has to be one or the other here. And then 22/11. Again, we see fraction right away, but if you simplify that, that simplifies to the whole number of 2. Any positive counting number is natural, which is also whole, also an integer, also rational, and also a real number. All right, representing integers. The next thing we're going to be looking at is identifying whether we have positive or negative integers given a scenario. So just some keywords to think about. Withdrawal is when you take money out of an account. Even though money comes into your hands and that's nice for you to be able to spend money, your bank account is going down, which is bad. And deposit is when you're putting money into the account. So even though it's being taken from your hands, it's being put into your bank account's going up. That's a good thing. Altitude is the height of an object. Like if you're in an airplane, you're at a certain altitude in the sky, that is positive. Depth is the distance from the top to its bottom. So depth is going down, that's negative. And then profit or income is money earned or money received. So we've got a hiker climbs to an altitude of 900 feet. So basically we're taking our number 900, we're deciding is it positive or negative. I see the keyword of altitude, and we're talking about climbing up. That is a positive value. Number 2, you have a debt of 24. The keyword is debt. If you are in debt, that means you owe money. This is a negative value. A student loses 5 points for being late to class. Losing points, that is negative. That is not good. Wendy's made a profit of $150,000 this month. Making a profit, that means you made money. That's a good thing. So that is a positive value. And then number 5, Mr. Benson went to the bank and withdrew $200 from his account. So we're going to think about this in 2 scenarios. What integer represents the change in amount of the money in his bank account? Well, when he's withdrawing money, his bank account's going down, so that's negative. What happened to his wallet? Well, he put the money in his wallet, so his wallet amount went up. And then the last part is looking at 0. So as we talked about, 0 is kind of our special case scenario. That's why it's not a natural number. The number 0 can have different meanings based on real-world context. Sometimes 0 represents an amount that does not change, and 0 can be used to represent real-world ideas such as sea level. So if you're given a scenario for number 6, at the beach, John saw a bird flying at 50 feet in the air and a fish swimming at 5 feet below sea level. What does 0 represent in this situation? So we are talking about, we have 0, we have a bird in the air, we have a fish underwater. So 0 is representing sea level. That is the neutral ground there. It's the middle of the positives and the negatives. An integer to represent the bird. Well, the bird was in the air 50 feet, so positive 50. The fish was 5 feet below sea level, which is negative 5. Number 7, Tom works on the 4th floor in his office building. When he drives to work, he parks his car in the parking garage, which is 2 floors below the ground. So we're looking at, we have our 0, we have his office, and we have his car, which is below ground. So what does 0 represent in this situation? Our 0 is the ground or ground level. So representing his office is on the 4th floor, so that's positive 4. His car is parked 2 floors below the ground, so negative 2. And the last one, Angela has negative $35.62 in her bank account. What does a value of 0 mean in this situation? 0 means a balance of 0. Or doesn't owe money. What does this value tell us? Then that her value is negative $35.62, that she owes money. And the last thing with zeros is, let's look at just special case scenarios with 0. So if we're looking at 4 over 4, that equals 1. 3 over 4 equals 0.75. 2 over 4 equals 0.5. 1 over 4 equals 0.25. So